The next black hole adjacent question I had was why they and maybe it's not often, maybe I'm wrong to use this word, but why they form binaries that orbit one another. So one thing I imagine is possible is that, for instance, if our solar system had initially been the mass had been distributed differently, we might have had two stars that orbited one another as the solar system formed. Like, I don't know, maybe Jupiter could have been a star, for all I know. But I also have the sense that, like magnets, stars in different solar systems can form black holes and then sort of start to orbit one another. So, are there multiple ways in which black holes will form these pairs and start to orbit one another, or what is the general way in which this happens?
Yes. So my brain is bursting with a gazillion answers. Let me try to collate them. So yes. So number one, most stars do form in pairs. In order for those stars to become black holes at the end of their lives, they have to be very massive. So more than, 30 or 40 times the mass of the sun. So when they go supernova at the end of their lives, they can form a black hole. But they don't necessarily form black holes at the same time. So what can happen is that you can have a star that's in an orbit with a black hole, and that sometimes some of the gas from that star falls into the black hole, and the black hole can create jets, and then you can, see the system from really far away. So that gas from the star can also form one of these, small accretion disks around the black hole. And in fact, Cygnus X1, which was, I think, the first candidate black hole in our own galaxy, was found through, this kind of technique of looking at X-rays that came from the superheated gas, because you had a star that was orbiting, nothing, right? And that was the black hole that was causing that. So what can happen then at the end of the star's life is that it can also become a black hole if it doesn't, lose a lot of material. And then you have two black holes. And then over time, those will slowly merge and form a new black hole that just has, the first mass plus the second mass minus 5% of gravitational wave energy, because E equals mc squared. So that's one way of forming them. But in fact, you can have black holes that form through very dynamical scenarios. So around our galaxy, we have these things called globular clusters. And there's this loose collection of stars and potentially and some neutron stars and potentially some black holes. And there it's very dynamic. So there you can have black holes that are being captured and slingshotted. And then you can have very random encounters where you can have something like a head-on collision of two black holes, or you can have a very short timescale evolution. And you can actually tell, we believe, what the formation path was of these black holes by looking at their spins. So with LIGO, you can tell from the gravitational wave signature what the spins are of the black holes. And so if the spins are aligned of the black holes, it means that they probably formed through the first scenario, right? They were both stars, they co-evolved, they eventually merged, and their spins are aligned. But if they're forming in these very dynamic environments, the chances are that one's going to have a spin that's that has nothing to do with the spin of the other one. Their spins are completely, misaligned. And so by looking at things like spins and the gravitational waveform that you detect with your detector, you can, have strong evidence for the history of that, pair of black holes and where they came from.
Well, I have a question about the first scenario that we talked about. So you said that most stars form in binaries. And I think most people imagine, and hopefully we can dispel this if I'm right, that if a star becomes a black hole, it just immediately sucks in everything around it. But my understanding is that if one of these stars becomes a black hole, I mean, its mass remains stable, and its mass is going to be the driver of the gravitational force it exerts on everything around it. So if they're already stably orbiting one another, the fact that one of the stars becomes a black hole isn't going to have any effect necessarily on the other star. So it can go about its merry way for another few million years or however long it takes until it too goes black hole. Is that correct?
That's right. Yes, that's
Okay.
absolutely right.
Okay, great.
And in fact, I think a really intuitive example of exactly this is if you were to take the sun and turn it into a black hole with the exact same mass, nothing would change in our solar system. It would just get really cold.
Yeah, exactly.
The
Really
like
cold and dark.
dynamics, yeah, the dynamics in our solar system wouldn't change. So you're exactly right. The most important thing is the mass, and that's really the driver of everything.
Yeah, I think that that's the biggest misconception people have about black holes. Like I was very like the Earth could conceivably, if it became dense enough, be a black hole, and we could just the moon would just continue orbiting about it happily.
Mm-hmm. Yeah, that's right. The most important thing is the math. That's exactly right.